Okay, in today's video, we're going to be going through memory management and what ways you can manage your memory. To start with, I want to say that when we make a C program, then our variables are stored as memory addresses, as we went through it before in the previous video. And now it's important to know that these memory addresses are stored in our RAM. Now, there are two types of memory allocations or ways to allocate or store your memory. And one of them is one that we don't think much of, which is the static memory allocation. And this happens during the compile time of the program, which is when the program automatically itself allocates memory. And then there is another one, which is the dynamic memory allocation, and it's when we ourselves allocate memory manually. Uh, the dynamic one has a couple functions. One of them is malloc, we have calloc, and we also have realloc. Now, today we're going to be going through mainly malloc and how to use it. Now, as I said earlier, malloc is a way to allocate memory in a program, and by using it, we would get returned a memory address that malloc has given, which is in the form of a pointer that points to a certain block of memory malloc has stored for us. Now, I'm going to give you an example of what malloc looks like, and I've created a little thing just to maybe make it a little bit easier to understand. Uh, so, first of all, we define the type of a pointer, which is the int, and then we can call this a or we can call this ptr to have it easier. Ptr is the name of the pointer, and then we usually don't really have to do this because it still works, but we're gonna cast int with the asterisk sign to avoid errors. So this is more formal to do it this way. And then we call the malloc function, and this is the dynamic allocation. This is malloc itself. And to use malloc, you also have to use it with the size of. And size of is the function that defines the size of the block and how many bytes we're going to need. So this says how many bytes, and this says which type of bytes we're going to need. And this one over here says the amount of bytes that we're going to be using. So to create a little program that works with this, first of all, we have to include stdlib.h because this is the library that malloc exists in. And if we want to use this, we see that we have assigned 2 bytes to this function, which means that we can only print out p of 1, p of 0 actually, because index starts from 0, and then p of 1. And if you want to print out these, we can give them values actually. And let's say we would give them the value of 10 and the value of 20. Now, we can call them like this just to make it easier when we print it out. And now we want to call the function that we're printing out. So now we have said that we have malloc that has stored 2 bytes of memory for us. And in these 2 bytes, we have p of 0, which is 10, and p of 1, which is 20. And we're printing out the first one and the second one stored in the memory. Now, we're not completely done here. When we always dynamically use memory, we have to always remember to add free ptr at the end. And what this does is that it's important to free the data after being done with the program for the space to be used again in the future. So if we don't use the free space using free PTR, then no other program can use that space. This means that our memory can be filled and perhaps end up crashing. So always remember, especially when working with big programs, to always use free PTR. And basically, just to sum this up, you know that if you don't free your memory, you can end up having issues such as memory leaks, which is basically just a result of losing memory and corrupt memory. So always remember this when you use this. And then now if we print this out, it's not gonna let us. Um, oh yeah, we call this P. It's supposed to be PTR. There we go. And same over here. My bad. And then you see the first is P of 0 is 10, and then second P of 1 is 20. All right, thanks for today.